Evening, sir.
Good evening, everyone there?
Yes, sir.
Yes. Okay. Fine. Shall we start?
Yes, sir.
Yes, sir.
Yes, we'll start. Before that, what happened in accounts? Why we were not in the classes properly? Because see, yes, sir has spoken in stretch. I do not want to bring that mood again. We want full focus now, but that should not be the approach, right? That should not be the what do you say, the attitude. It's not that we are doing revision sessions since we are free. No, none of the faculties are free, right? We are keeping our work aside and coming here. Why? So that we can put some value additions to your preparations. Yes, if we had not done these revision classes, yes, still you would have prepared, still you would have written the exams. I'm not telling no, but since you have already attended accounts paper now, since I've already written accounts mock test paper and valuation is done, now tell me, because of that revision, there is huge value addition in your preparation, the approach, correct? You will get that approach, which are the questions that we have to attempt, how we have to write the answers, right? How to decide on the examination day when you get the paper, which are the questions that I have to write, which are the questions that I have to write, in which order that I have to write, correct? These things definitely comes by experience, and no better than faculty is telling that, correct? Right? So take these revision sessions seriously. Specifically, it's not that I'm taking this subject. I'm telling this particular subject. If you can ask your friends also who have attended the last revision session. Many of them have cleared foundation. So we did exhaustive. We just did 4 or 5 sessions, if I'm not wrong, 15-16 hours, not more than that. We solved 600 questions in that. 600 questions individually. If we sit and solve, definitely it is not possible in 15-16 hours solving those 600 questions. It's not that we'll keep on solving 600. We still revise the concepts, we still remember, try and remember the formulas and then solve the problem. So it definitely can be done. And once we are solving 600 questions, all probable concepts, all possible concepts gets covered there, correct? So that helps us, that gives us the confidence. Ultimately in this particular subject, confidence is the thing, right? If we have that fear, definitely we cannot pass. If we have that confidence, 100% we can pass. So we should have that confidence. We should have that belief in ourselves. How do we get that? One, yes, we have to train ourselves. Second, we have to practice. Yes, once we have practiced, definitely we'll get that confidence. We'll get that hold in that subject, that we can pass, we can score well in this subject. Ultimately, our objective 80 plus math, stats and logical reasoning. Definitely possible. 80 plus, 100% possible. Minimum 60. Okay. For us, passing mark is 60. That should be our approach. That should be our mindset. Minimum 60, easily possible. Even during classes, I was telling the same. Correct. We have to divide this subject into 3 different concepts. And we all know statistics, logical reasoning, and mathematics. 40, 20, and 40. Logical reasoning, out of 20, we should get full 20, but minimum 15. Minimum 15 should be our target. We should get full 20. Full 20 easily possible. Maybe 1 or 2 questions here and there. So we can easily get 18, 100%. Then statistics. Statistics, out of 40, 25 is minimum. 25 is minimum. 25 to 30 that we can target there. And mathematics, even if you get 15, 60 is the marks that we have got. 20 in logical reasoning, 25 in statistics, and 15. 60. So easily possible. Okay, so getting 60 is easily possible. We have to have that approach. How do we do that? During the courses of the session, definitely we will discuss. That is the first thing. Now, second, certain chapters that we have to focus on. Right? In statistics, if you focus on the first 2 chapters, anyhow, we'll start with those 2 chapters itself today. So first 2 chapters, if we focus on, we'll get 15 marks, 15 to 16 marks. Right? First 2 chapters, 15 to 16 marks. Same way in mathematics, time value of money, 1 single chapter, 12 marks minimum. Okay. And what is there in that? 6 to 7 formulas. That's it. Correct. Time value of money, if you remember. So it's easy, provided we have the right approach. We will fear about calculus. We'll fear about probability. We'll fear about the theoretical distributions. We need not worry about those chapters at all. Even if we completely ignore those chapters, we still get 60. Okay, and it's not that in those chapters none of the questions can be answered. No, there will be easy questions from those chapters also. Correct. So focus on those easy questions in those chapters. Focus completely on these 3 chapters that I spoke about, plus logical reasoning. Which are those chapters which you feel difficult? Those chapters, focus on easy questions. Okay, don't completely ignore those chapters. Focus on easy questions. There will definitely, if 5 questions are being asked from this chapter, definitely 2 questions would be easy. Okay, 2 questions would be easy. One would be midway, and the other 2 definitely would be a little tricky. Okay, even if we ignore those 2 questions, it's okay, fine. Still, we can definitely get our target, definitely reach our target. Okay, that's one point. Second is negative marking. We will have that fear whether to answer the question, right? What if that goes wrong? Negative. So there are instances where we find some of the students answer only 45 questions. Only 45 questions, but still, by God's grace, they would have passed. Fine, that's also fine, but that would be dangerous. What if there would be some wrong answers in those 45? Correct. Why only 45? Why not the other 55? They would have known the answers, but they're scared to answer it. So in such cases, how do we decide, right? Whether we have to answer certain questions wherein there is 50-50 chance of getting the right answer, whether we have to go ahead and answer or back away and not answer. So that again, we have to decide on our own. How do we do that? We'll again discuss about it in detail while solving the problems. Okay, so that is one major thing that that will impact. So these 2 points that we have to focus. One is purely preparation point of view, practicing point of view. Second is from examination point of view, answering the questions, what questions to be answered, not to be answered. Is that clear? Yes. For this 2 conditions, same conditions, whatever sir would have told. Complete interaction. If interaction is not there, definitely is not possible for me to solve those 600 questions. Then I might have to cut short 200, 250 questions. I'll complete it. If it has to be completely solved, full interaction should be there. Everyone should answer. Second, video on. Video compulsory, it has to be on, and everyone should attend all the sessions. If these 3 conditions are fulfilled, definitely we'll do all 600 questions. Clear? Done? Deal? Everyone?
Yes,
Everyone?
Yes, sir.
Yes,
sir.
Yes, sir.
But still, for this purpose, it is a valid contract. Everyone deal?
Yes, sir.
Yes, sir. Yes, sir.
Okay, fine then. We'll start with the session. For how would be the session? How would we go is we'll target 2 to 3 chapters at one cluster. We'll first look into all the concepts that are there in that chapters, or what are the formulas that gets covered. We'll discuss that, come back, solve problems with regard to those chapters, and again move on to the next cluster, next set. Correct? That is how we will do. So what we have to do, we have to focus on formulas compulsorily. During the regular classes also, we have written those formulas at the end. Very, very important. Now those exercises that we would have done, the last page that we have written those formulas, now it will help us. Why? Now we have to keep on revising those formulas during our preparations. So now we need not go through those materials again in between the materials. We have to just go to the last page of our notes. We'll have all the formulas in place. If there are some formulas missed out, you can fill down during the revision classes. You can just fill it up so that your formula set is ready for revision. Correct? That can be done. Again, remove the fear in your mind. Even still, there could be some students who have fear. Normal, it is normal. Don't worry about it. Remove that fear. Just enjoy these revision sessions. Definitely you'll get the confidence. Okay, that is the first. Okay, we'll start with the first chapter. We'll start with statistics now. We'll start with, we'll target 2 chapters. First one, statistical description of data, and second one is measures of central tendency. Very important chapter. So we'll focus. I'm not sure whether we can finish those 2 chapters with the problems in today's session. We'll see how it goes going forward. Okay, fine. Statistical description of data, completely concept based, right? Very easy. 4 to 5 questions would be asked, and easily we can score all 4 to 5 marks. What we have to do, we have to just go through these points that we have in this revision material. This material will be shared with you. Revision material will be shared. Don't worry. It's already in the pipeline, so it will be there in your group. So statistical description of data, each and every point in this notes can be a examination question. So be very careful. Am I audible properly?
Yes, sir.
Yes. Okay.
Yes, sir.
Right. So statistical description, to start with, we have statistics. Definition of statistics. First one is origin. The word statistics, they say it has been originated from 4 different languages: Latin, Italian, German, and French. Latin status, Italian statista, German statistic, and French statistic. Spelling difference. This can be asked. Till now, it's not been asked, but can be an examination question where then they can ask it as a odd one out. Where they can give one different language altogether and ask us to identify which is the odd one out. So might be important. When coming to definition, there are 2 definitions. One is as a plural noun. Second one is as a singular noun. As a plural noun, what is statistics? The data itself. The data that you have collected, the data itself will be considered as statistics as a plural sense. Easy to remember. Why it is plural? Plural means more than one, correct? So data will always be enormous, huge. So more than one, plural. So the data collected, plural. What is singular? The process involved to collect the data, various processes: collecting the data, analyzing the data, presenting it, classifying it, right? So there are various processes involved. That process or the method is called statistics in the singular sense. So plural and singular. There are various advantages of statistics. It's used in almost every area, right? Whereas limitations become important. Advantages are not so important. Limitations become important. Statistics deals with aggregate. What do we mean by this? If we have one single data mark scored by Sri Saujanya, we cannot do anything. One single mark. However, if we have marks scored by all 93 of us in the class now, we can analyze. Correct? So it deals with aggregates. It deals with aggregates. And it is concerned with quantitative data. We cannot analyze, or we cannot have statistical analysis of behaviors, of qualitative data. It requires quantitative. Even if we want to analyze qualitative data, we have to convert qualitative to quantitative, correct? So deals with only with quantitative data and future projections under specific conditions. Now we have discussed correlation and regression in our regular classes. Anyhow, we'll be discussing that. In that regression analysis, what is regression? Based on an established relationship, we'll be projecting the value of one variable given the value of the other variable. If I know the value of X, then I can project the value of Y based on relationship between X and Y. Now, that value of Y that you are projecting will be correct only if the relationship was good between X and Y. If the relationship itself is wrong, then the projection also goes wrong. Therefore, future projections under a specific condition only. Only if that condition satisfies, your projection is right. And at any point in time, statistics, we go with sampling. It's not possible for us to consider the entire population. So the inferences, the conclusions that we get is based on sampling, random sampling. So these are the 4 disadvantages of statistics. It deals with aggregates, deals with quantitative data, then specific condition, the projections that we are making, and the last one, it is based on sampling. The conclusions that we get are based on sampling. Clear?
Yes, sir.
Yes. Okay, fine. So the basic or the base behind statistics is data. Right? Unless there is data, there is no statistics at all. So data, there are of 2 types: qualitative data, quantitative data. What is quantitative data also called?
Variable.
Variable. Very good. Qualitative data?
Attributes.
Quantitative data is called attributes. Full stop. No further discussion with regard to attributes. Whereas variables, we can further divide them into 2 different categories: discrete variable and continuous. Yes. What is discrete variable? Where the number of values that it can take can be counted. Number of values that it can take can be counted. For example, number of petals in a flower, we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There cannot be 1.5, 1.35 petals, 1.45 petals. No, not possible. So the number of petals can be counted. Number of misprints in a book contains, we can count 1, 2, 3, 4 mistakes, typo errors, correct? Number of road accidents in a particular locality. So these are all countable, simple for our understanding. If that particular experiment or that particular event can be presented in the form of decimals, 1.33, 5.25, etc., then it is not discrete. Only if they can be presented in whole numbers, 1, 2, 3, 4, 5, 6, 7, 8, then it is discrete. Okay, discrete variable. The other is continuous variable. It can take any value in the given range. For example, heights of students. So even if we say the range is 150 to 180 centimeters, in 150 to 180, it can take any value, 150.33333, 150.325, right? So it can take any value in that particular given range. Such variables are called continuous variables. Such variables are called continuous variables. Height, weight, sale, profits, and so on. It can take any value in the given range. Whereas qualitative characteristic, that is called as attribute, we have discussed this. Now, in data, now till here, any doubts? Anyone has any doubts? No? Okay, fine. In data, now we have discussed that there are two types of data, qualitative and quantitative. This is based on the nature. Based on collection, now for statistical analysis, we have to collect the data, correct? For collection, based on collection of data, we have divided the data into two types, primary data and secondary data. What is primary data? Fresh data. We ourselves are collecting the data, first-hand data. Whereas secondary data is already collected by some other organization, some other person. We are relying upon the data collected by them. Right? So if we ourselves visit and collect the data, that becomes primary. If we go with the data collected by any organization, and based on that, if we do our statistical analysis, that becomes secondary data. So since in case of secondary data is already collected, the problem of collection of data doesn't arise. Therefore, the different methods of collection of data comes into picture only in case of primary data. Right? Only in case of primary data. There are various ways of collecting. First way of collecting the data is interview method. What is interview? We just ask the question and collect the data, correct? In interviews also, we have three types: personal interview, indirect interview, telephonic interview. Indirect. Okay. Personal, indirect, and telephone. Now, what is personal interview? As the name itself says, the interviewer will personally visit that particular area, personally ask questions to the respondent, then get the information, right? So personal interview, investigator meets the respondent directly and collects the required information then and there from them. For example, natural calamity, whenever their compensation has to be given, etc., there they go for a survey. So in there, they'll visit the victims personally. They'll ask that about the damages, get information about the damages, and accordingly file a report. That comes under personal interview. Whereas indirect interview, what happens in case of indirect interview is the personally visiting and personally asking the respondent, the direct victim, might not be possible. In such cases, we will go and ask the questions to those people who were witness to that event, who were indirectly involved in that event. For example, train accidents. So in case of train accidents, there will be loss of lives, there could be injuries. So we cannot go and visit, go and ask questions to those persons who are injured. There could be serious injuries. There will be in hospitals, or obviously we cannot ask dead people. So in such cases, what do? We have to go and ask the persons who have seen that accidents, persons who were there in the platforms, near the platform, or near those areas who have seen victims. So that is called indirect interview. If there are practical problems in reaching the respondents directly, then conducting indirect interview where investigator collects the necessary information from persons associated with the problems. Indirect. Telephonic interview. In the first two cases, interviewer will personally visit. Whereas in the third one, telephonic interview, what happens? He will not visit, he will get the information through phone. Right? Telephonic interview, he will collect the information through phone. So it is a quick method. So time involved is less, and it is non-expensive as well. we can reach more area. We can reach a larger area in a lesser time period using this. However, what is the disadvantage? Telephone.
Non-responsibility.
Non-responses. Right? Then when we ask the question directly, personally visiting, they are bound to answer. But when we ask the same questions over phone, there would be non-responses. So non-responses would be high in case of telephonic interview. So though it is less consistent, we can cover a wide area, but the non-responses would be maximum. These can be asked. These are the points that they will focus on in exams, right? What is the advantage of telephone over the other two interview methods? That could be the question. Or what is the disadvantage of telephone interview over the other two interview methods? So accordingly, we have to answer. Advantage would be we can cover a wide area, but disadvantage would be the non-responses. This is interview method. Second one, mailed questionnaire method. In mailed questionnaire, what do we do? As the name itself says, questionnaire. We'll prepare a questionnaire. Whatever data that we require, we convert them into questions. We frame questions and we'll draft a questionnaire. And we will not personally visit. Instead, we will mail it. It could be through electronic mail or physical mail. We will mail it. The respondent has to fill in the responses and send it back. Fill in the responses and send it back. Obviously, what happens here? Non-response. Non-response would be higher. Again, we can cover wide area. It's just we have to just send it through post or through email. So we can cover wide area, but non-responses would be higher. Wide area can be covered. Number of non-responses would be maximum. Third one, observation method. Here, we are not asking questions. Unlike interview or questionnaire, no questions at all. But we are getting the information how? By observation. We are getting the information by observing. For example, collection of the data of height and weight of students. So there, the students would come, stand near the height scale or the weight scale. Accordingly, the person who is collecting the data, he'll just observe the data, observe the whatever height or weight that that student is, and accordingly fill in the data. Correct? So no questions would be asked. Just by observation, the data would be filled. That's observation method. What is the disadvantage here with regard to time? Cost. Correct. It's very time consuming because personal touch is very much involved. The person who is collecting the data, he should be capable of doing it. So it's time consuming and laborious. But advantage is the reliability of the data, accuracy. Accuracy is the data is more accurate than the other methods. The last one is questionnaire. The difference between mailed questionnaire and questionnaire is they will have the same set of questions. They'll have that questionnaire, but here they will not mail it. They will the respondent's place, ask questions, fill in the answers, and come back. So, example, census. Right? So, used for larger inquiries from the persons who are surveyed, enumerators collect the information directly by interviewing the persons having information. Questions are explained, and hence data is collected. Clear with this? These four methods. Sleeping.
Yes, sir.
No, sir.
No, sir.
Clear with the topic.
No, sir.
There was a lag in answering the question. Two questions at a stretch. So we have to be careful while answering. Next, sources of secondary data. Now, as I said, in case of secondary data, what happens? Data is already collected. So no confusion or no problem of collecting the data again. Correct? So we have to just look into from where we can get those secondary data sources. It can be local sources to global. It can be international sources like WHO, ILO, IMF, World Bank, etc. Could be government, national level sources like government sources, statistical abstract by Central Statistical Organization, Indian Agricultural Statistics by Ministry of Food and Agriculture, private or quasi-government sources like ISI, ICAR, NCERT, and unpublished sources as well. Various universities, they have their own research wing. There also you can get the data. Right? These are all the sources of secondary data. Now we have understood how to collect the data. Right? How to collect the data. Once the data is collected, can we use the data directly? No,
sir.
we have to see whether the data collected is in the right order, whether the data collected, the entire data collected is useful, or there are some irrelevant information available there. And moreover, we have to see whether the data collected is in proper manner. That is, whether it is reliable. The data collected is reliable. So for that, what do? We will scrutinize the data. We will scrutinize the data. How do we scrutinize the data? There are various techniques. There is no set standards for scrutinizing. It depends upon the person who is scrutinizing the data. Just for an example, in case of questionnaires, census reports, when they bring the reports, in the initial stage, we will have the basic information, number of people in that house, 2 adults, 2 children. So in the subsequent details, the schools in which the students are learning, in that they should have 2 entries, because there are two children in that particular house. So if there are more than 2 or less than 2, then data collected is inconsistent. Correct? So accordingly, you have to ask the enumerator to again rectify it. And in some cases, what could happen? The enumerator is lazy, like some of us, to visit all 10 houses allotted to him. So instead, what he'll do, he'll just go to one house, collect the information, copy paste all 10 reports. So that you'll get to know by looking into the reports, by comparing the answers in the reports. Correct? So these are some of the ways in which you can scrutinize the data. Once you have scrutinized it, we need to classify. Data should be in proper order, proper structure for analyzing. Correct? When best simple analysis, calculation of arithmetic mean. To calculate arithmetic mean, we should have the data in a proper order. We should have the class intervals, frequencies in place. Only then we can calculate arithmetic mean. Correct? So for that, classification becomes important. With regard to classification, there are 2 different ways of classifying. One is frequency group. Second one is non-frequency group. Frequency group, which we have already learned, qualitative data, quantitative data. Correct? Now, in that, qualitative data is also called as ordinal data. Quantitative is also called as cardinal data. Can be asked. They can confuse us. They can confuse us by not using quantitative, qualitative. They can directly use ordinal, cardinal. Right? So we should know which is ordinal, which is cardinal. Cardinal means quantitative. Ordinal means qualitative. Cardinal is numbers. Ordinal is no numbers or qualitative attributes. Whereas under non-frequency group, based on time, based on area, chronological data, geographical data. Based on time, it is chronological data. Easy to remember. Chronology, we all know. Chronological or temporal or time series. Based on area, it is called geographical or spatial data. Okay. This is classifying. Once we have classified the data, we need to present it somehow. Right? Either it should be in the form of a table, in form of a text. So presentation, there are 3 different ways of presenting. What are the 3 ways? Textual presentation, tabular presentation, and diagrammatic representation. What is textual presentation? Bringing the information in the form of a text, paragraph, article, writing articles. Correct? So yes, writing articles, bringing it in the form of paragraphs is simple. There is no rules as such that we have to keep in mind, etc. But it becomes dull, monotonous. Comparisons between those different observations, not possible. It's obviously not attractive. Reading an article is not attractive, obviously. It will have the same information as a table, but we'll focus on the table, not the paragraph. Correct? So it's dull and monotonous, and comparison becomes difficult. Why? Because when we have it in paragraphs, let us say the information of 2018 is there in this paragraph, 2020 is there in the other paragraph. Then in order to compare, I have to go back to each paragraph again to get the information. But if I have the same in the form of table, 2018, 2019, and 2020, I can easily compare. Correct? So comparison becomes difficult in case of textual presentation. Because of that, because of these disadvantages, we normally go with tabular presentation. This is the best mode of presenting the data. Tabular, table, presentation in the form of table. Statistical table. What's the advantage? What was the disadvantage here? Comparison. That's the first advantage. Comparison is possible. It facilitates comparison. And how much ever complicated the data is, we can bring it in the form of a table. And For any further statistical analysis, simple example that we took was arithmetic mean. We want the data in the form of a table, correct? Statistical analysis is not possible without tabulation. And the next discussion that we have, diagrammatic representation of data. Any diagram that we are talking about there, data must be there in the form of a table. So tabular presentation is a must for diagrammatic representation. These are the 4 advantages. However, how do we prepare a table? Now, every table should have a table number, serial number, and it should have a title, correct? And table, inside the table, it is divided into 4 parts. The upper part, the entire upper part of the table is called
Caption.
Box head. Box head.
Interchange order. The entire upper part is called box head. The columns are called
Captions.
captions. This is called captions. Whereas these row heads are called stubs. And the area where we write the data, where we
Body
present
of the table.
Yes, that's called the body of the table. The top of it, we'll have the title, table number and title. Below the title, if title should always be crisp and short. Below the title, if you want to bring in some further information which is required, that is called head note. Footnote will be down, head note will be up, right? Head note. And at the end, we will have footnote that can contain
Source.
Yes, that can contain abbreviation, source, etc. Right. Okay, so it will have 4 parts. Table should be well balanced in length and breadth. Arrangement should be such that comparison becomes easy. What are the different parts which we have already learned, discussed now? Table number, title of the table, caption is column heading, stub is row heading, body contains the data, head note, something that is not explained in the title. Captions or stubs can be explained in the head notes on the top of the table, just below the title. Footnotes, source of the data, some exception in the data can be given. Table under consideration is divided into box head, stubs, and body. Caption is the upper part describing columns and subcolumns. Box head is the entire upper part of the table, includes columns, subcolumns, units of measurement along with captions. Stub is the left part of the table describing the rows. Body is the main part of the table that contains the numerical figures. The main focus where the data is, correct? This is how we present the data. Clear till here?
Yes.
Yes, sir.
Standing.
Sir, if we write the figures in millions or in thousands, will it constitute a box head or caption, sir?
No, see, figures in thousands will always be units of measurement, which is just above the table, correct? Here, we'll write.
Yes, sir.
That will be part of the box head. Caption is only columns. Columns plus whatever you write in units of measurement, etc. together is called box head.
Okay, sir. Thank you, sir.
So that is tabular presentation. The next one is diagrammatic representation. So what is the advantage of diagrammatic representation? Attractive. Correct. It is attractive. And even if the person who is looking into that information, even if that person is not learned, he's not gone into education, uneducated, even that person can understand the diagrams, and any hidden trend in the data can be easily noticed using diagrams. For example, line diagram. If I draw the line diagram, then I can easily understand the trend of increase wherever there is increase. That might be a little difficult in case of tabular presentation, right? However, disadvantage is it is less accurate because we will go with estimation, right? We will draw it in graph wherein we'll estimate 1 centimeter is equal to so and so units. So since we go with estimations, it is less accurate when compared to tabulation. Yes. The types of diagrams. First one we have is line diagram. Line diagram is used when data vary over time, obviously. Now, what do we do in case of line diagram? Normally we will have 2 axes, correct?
X-axis and
X-axis
Y-axis.
will always be, normally will be the time, years, correct? This would be the units, wherein accordingly we will plot the points in the graph and join the plots through
Lines.
straight line. That is the characteristic of line diagram. It should always be straight line. There should not be any curves there. So plotted points are then joined successively by line segments, and that resulting chart would be line diagram. This is simple line diagram. If there are huge fluctuations in the data that we have, then we might, it's not to use the plain line diagram, we go with logarithmic line diagram or ratio line diagram. Okay, logarithmic chart or ratio chart. In that case, we will, in the y-axis, we will plot log values. However, if we have same units but multiple time series data, we have wheat production as well as rice production to be presented in the same line diagram. Units are same, then multiple line chart. If we have wheat production and milk production, units are different, then multiple axis line chart. Multiple axis line chart. These are small points which become important. We understand what is a line diagram. If we have wide range of fluctuations, then we use
logarithmic
line chart. However, if we have two or more time series data, 2 arrow marks. If the units of measurement are same, then
multiple lines.
Just multiple line chart. If units of measurement are different, it would be multiple
axis
line.
Axis line chart. Understanding the difference?
Yes, sir.
Yes. Important discussion. These two specifically, the difference between multiple line and multiple axis line becomes very important. In both cases, we will have 2 or more time series data. The only difference is in multiple line, the units of measurement would be the same. In multiple axis line, units of measurement would be different. Next one, bar diagram. In case of bar diagram, similar to line diagram, but instead of straight line, we will have like rectangular bars presenting the data. Correct? Rectangular bars. So there are two types of bar diagrams: horizontal, the one that we did, and vertical bar diagram. Horizontal bar diagram used for qualitative data or data varying over space. Vertical bar diagram used for quantitative data or time series data. Now, same bar diagram, if you want to compare production of wheat and production of rice together, that is called multiple or grouped bar diagram. Multiple bar, similar to multiple line chart, multiple bar diagram. You do not want 2 bar diagrams. You want only 1 bar. But inside that, you want to divide it. This is rice and this is wheat. Yes, this is called component or subdivided bar diagram. Component, we are dividing, subdividing it, correct? Same way, you do not want, now this is in tons. Let us say this is 50 tons and this is 60 tons production of rice and wheat. You do not want it in tons, you want it in percentage. So what you will do, will convert everything in percentage. The single bar represents 100%. In that, some 45% represents rice, 55% represents wheat. This is called percentage bar diagram. This is called percentage bar diagram. Yes. So what did we discuss in case of bar diagrams? If we want to compare the 2 or more units, 2 or more time series data in a single bar diagram, in a single chart, we can do it by bringing for one single year, we can have multiple bars. That is called multiple bar diagram or grouped bar diagrams. Whereas you do not want multiple bars for a year. For 1 year, you want only 1 bar.
Component bar.
Inside that bar, you want to divide them. That is component or subdivided bar. Right. But in the same single bar diagram, you do not want them in actual figures, actual tons, actual kgs, etc. Instead, you want it in percentage.
Percentage
bar diagram.
In percentage bar diagram, that bar represents 100%. In component or subdivided bar diagram, that bar represents total production. For example, if there was 50 tons of wheat, 60 tons of rice, that bar represents 110 tons. That bar represents 110 tons. Understanding?
Yes, sir.
Yes. Okay, fine. So this is how we present the diagrams in using a bar diagram. The last one that we have is pie chart. In pie chart, what do we do? We convert the data into
360 degrees.
very good degrees, 360 degrees. Easy. How do we convert?
Angle divided by total angle into 360 degree.
Divided by total angle into 360 degree. Yes, angle that is tons divided by total values divided by total values. If you have 50, 60, 80 and 100 as the total, as the values, given values, you will add it up. 100 plus 80 plus 60 plus 50, you get, I think, 290. This you have to represent in terms of degrees. So this is 50 out of 290. What would
In
be for
360 degrees.
50 by 290 into 360. This is how you will convert them into degrees. Correct? Can be asked. Obviously, they cannot ask you to draw pie chart in the exam, but they can ask you to calculate the degrees. Possible. Can be asked. So once you have the degrees ready, then you will draw a circle and divide these circles based on the degrees that you have computed. That is pie chart. So these are the different diagrammatic representations that we have. Again, this is diagrammatic representation of data. This is not the first presentation. You will have it in the form of table. From the table, you are representing it in another form. That is diagrammatic form. Clear?
Yes, sir.
Yes, sir.
Yes, sir.
So with that, we are done with diagrammatic presentation. So presentation is done. In tabular presentation, the presentation in the form of table, there are chances that one single value is repeating multiple times.
Yes, sir.
So if one single value is repeating multiple times, what do we call it?
Frequency.
Frequency.
What is frequency? The number of times a particular observation has repeated. So if we have frequencies captured, such distribution is called frequency distribution. Correct? It's called frequency distribution. Now, how do we construct a frequency distribution? There are two types of frequency distributions: discrete frequency, continuous frequency. That depends upon the variable that we have. Discrete variable will have discrete frequency. Continuous variable will have continuous frequency. How would a discrete frequency distribution look like? It will have X and F. X values of 0, 1, 2, 3, 4. F values of 25, 30, 45, and so on. Correct? Whereas in case of continuous frequency distribution, you will not have X, you will have
Class interval.
class
Class interval.
10 to 20 and so on. So this is continuous, this is discrete. How do we construct a frequency distribution? We have to find out the range in the data, find out the highest value, lowest value, highest minus lowest, that's the range. From that, you have to calculate the number of class intervals. Range divided by
Width of the class interval.
yes, class size or the width of the class interval. Range divided by class size, you will get number of class. So let us say we get 4.3. Should I choose 4 class intervals or 5 class intervals?
5 class intervals.
5 class intervals.
Should always be the next number. It should always be the next number. So 4.3 should be rounded off to 5. Should always be the next number. So once we have the number of class intervals, present the class intervals, which should be the first number, the lowest value. Lowest value in the given range would be the first to start with. You will start with that. You present the class intervals in the form of a table, and then you have to assign the values to each of the class intervals. How do we do that? We will assign tally marks. Correct? We'll assign tally marks. For every value, you will assign a tally mark in that respective class interval. So if we have 0 to 10, 10 to 20, if we get 10, in which class interval do you classify it?
Second class.
Second classes.
You will classify it in the second class interval because this is mutually exclusive. Exclusive. The upper limit should be excluded. The upper class limit should be excluded from the class. Very good. Then once we have all the tally marks done, you will count the total tally marks. That gives you the frequency of that class interval. thereby you have the frequency distribution table. Correct? Now, in this frequency distribution table, there are very important concepts that we have to see. Class limits. Class limits, maximum and minimum value of the class interval. So 0 to 10, 10 to 20. For the first class interval, 0 is the lower class
Lower
limit. 10 is the
Upper class limit.
Upper class limit.
upper class limit. Same way, 0 to 4, 5 to 9, 10 to 14. 0 is the
Lower class
Lower class limit.
boundary.
What is the upper class limit?
Upper class should be 4.5.
What is the upper class limit?
Upper class limit is 4. Upper class boundary is 4.5.
Upper class limit. I'm talking about class limits now. Correct? Upper class limit 4. Correct?
4.
Upper class limit is 4. Same way for this. What is the lower class limit?
10.
10,
10. Class limit?
14.
14.
14. So class limit is easily identifiable. There is no computation involved. Just looking into the data, identifiable. Lower limit is lower class limit. Upper limit is upper class limit. Correct? Whereas in some cases, there could be further value which is below this lower class limit, part of this class interval, above this upper class limit, part of this class interval. That gives us the real limit of that class interval. We will call it class boundary. For example, if I get the value 9.8, it doesn't come in the class interval 5 to 9. It doesn't come in the class interval 10 to 14 also. Correct? From 10 to 14 means you have to count from 10. From 5 to 9 means you have to stop at 9. Where does 9.8 go under? 9.8 should be taken by this class interval. Even though 10 is the lower limit, it has one more limit lower to that lower limit. We call it lower class boundary. Lower class boundary is the real limit to a class interval. Same way, upper class boundary
14.
above the upper class. When do we have different LCB, LCL, UCB, and UCL?
When it is
Only in case of
inclusive.
Inclusive.
exclusive or mutually
Inclusive class
inclusive.
interval.
Yes. In case of mutually exclusive class intervals, LCL, UCB, LCL, LCB, UCL, UCB are
Same.
the same. Class boundaries and class limits are the same. Only in case of mutually inclusive class intervals, we will have different class boundaries and class limits. Clear with this?
Yes.
Yes, sir.
Yes. How do we find these class boundaries? Lower class boundary will be, see, lower class boundary would be lesser than lower class limit.
Yes, sir.
Yes, sir.
Yes. So it would be lower class limit minus, there should be something that you have to reduce from it because lower class boundary is lesser than lower class limit. So you
UCL.
will minus d by 2. We call this d by 2. What is d? I'll come to that. Upper class boundary is equal to upper class limit. Now upper class boundary is higher than upper class limit. So
Yes.
it should be added. Use plus d by 2. Now in this example that we took 0 to 4, 5 to 9, 10 to 14. For these two class intervals, they have to agree among themselves that from 9 to 10, 9.1, 9.2, 9.3, 9.4, 9.5, etc. Some values should be taken care by second class interval. Some values should be taken care by third class interval. That there should be an agreement. When there will be an agreement? Only when there is equally divided. Only when the data is equally divided. So first 0.5 values from 9 to 9.5, second class interval will take care. From 9.5 to 10, third class interval will take care. So how do we get this? You have to find the difference. 10 minus 9. What is the difference? 1. You have one value to be covered, which should be covered by both class intervals equally divided by 2. D is the difference. D is the difference between lower class limit of this class interval and upper class limit of the previous class interval divided by 2. D divided by 2. That is D divided by 2. LCB will always be lesser than the lower class limit. So LCL minus D by 2. UCB will always be higher than the upper class limit. So it would be UCL plus D by 2. UCL plus D by 2. Is that clear?
Yes, sir.
Yes, sir.
Yes. So this is
So can you
about
tell
class
D again,
limits.
sir?
Yes, Suman?
Can you tell the D again, sir? How to find out D?
D. Okay. D is the difference. Okay. So if we have 0 to 4, 5 to 9, 10 to 14. In this, when we discuss these two class intervals, there is a gap of 1, 9, 10 minus 9, 1, correct, between them. There is a gap of
Yes,
1,
sir.
that 1 have to be shared by both the class intervals. So this difference that have to be shared by both the class intervals is called D. Okay, difference between what is D? Difference between lower class limit of this class interval and upper class limit of the previous class interval. That is D.
Yes, sir.
Since they will share them equally, we go with D by 2. Clear?
Sir, where should we take 9.5?
Okay, that's again a good question. Where should we take 9.5? If we get exact 9.5, it should be taken to the second class interval. Why? Because from 9.1 to 9.5, it will be the second class interval. From 9.6 to 10, it will be the third class interval. 9.6, 9.7, 9.8, and 9.9 till 9.99999, it will be in the second class interval. Third class interval.
Excuse me, sir.
Yes.
If it is mutually exclusive, like 0 to 4, 4 to 5, 4 will take it in second class interval, no, sir?
Correct.
So like here also, 9.5, can't we take it in next class interval?
Okay. Understood question. See, that is when we are converting mutually exclusive into mutually inclusive. Right? When we convert mutually exclusive into mutually inclusive, if we have 0 to 9, 10 to 19, if you want to convert minus 0.5 to 9.5, 9.5 to 19.5, then agreed. 9.5 should go to the second class interval.
Okay, sir. Thank you, sir.
Okay, so this is about class limits and class boundaries. Any point should I give a note on, or any point you have confusions? Move on. Can we move on? Yes.
Yes.
Next one is midpoint. Midpoint or mid-value or class marker. This is easy. Where you, in case of midpoint, you can consider upper class limits, or class limits or class boundaries. What you have to do is you have to just add them, divide by 2. You will get midpoint. If you are going with class limits, upper class limit plus lower class limit by 2, class boundaries, upper class boundary plus lower class boundary by 2. Correct? But we cannot interchange. Upper class limit plus upper class boundary cannot be done. Sorry, upper class limit plus lower class boundary. No, it cannot be done. If you are going with class limits, both class limits. If you are going with class boundaries, both class boundaries, divide by 2, you get the midpoint. Length, where do we use this midpoint?
Continuous.
Very good. In case of continuous distribution, to calculate arithmetic mean, we want x. What is x? Midpoint. Correct? Yes, very good. Then length, width, or size of the class interval. How do we find the length or width of this class interval? It should always be class boundaries. Okay, don't go with in case of mutually exclusive, I'll go with class limits, mutually inclusive class boundaries. No, it should always be class boundaries. So if it is 0 to 10, 10 to 20, easy. Class boundaries are the class limits. 10 minus 0, 10 is the class size. Whereas if it is 0 to 9, 10 to 19, then you have to always go with class boundaries. What is the lower class boundary of this class interval?
9.5.
9.5.
What is the upper class boundary of this class interval?
19.5.
19.5.
19.5 minus 9.5, 10.
10.
10 is the size. If you had gone with class limits 19 minus 10, you would have got 9, which is the wrong answer. So class length or class size should always be based on boundaries. Difference between the boundaries. Next, we have cumulative frequency. Cumulative frequency is what? Adding up the frequencies. Now, when you're adding up the frequencies, there are two ways. Adding up from the beginning, adding up from the end. If you're adding up the frequency from the beginning, we call it less than cumulative frequency. Adding up from the end, we call it more than cumulative.
More than cumulative frequency.
When we say less than or more than, again, that is with respect from class boundary. Correct? With respect from class boundaries. Next, the last two concepts in this discussion, we have frequency density, relative frequency, percentage frequency. Now, frequency density, we are focused on on that particular class interval only in frequency density. Frequency divided by the class size will give the frequency density. Only in of that particular class interval. We will not go beyond that class interval under discussion in case of frequency density. But in case of relative frequency, what is relative frequency? Frequency of that class interval divided by total frequency into 100. So what percentage of the total, into 100, it's not into 100, into 100 becomes percentage frequency. Frequency divided by total frequency, that ratio that we get, that is called relative frequency. So what proportion of total frequency is there in that particular class interval? Relative frequency, frequency by total frequency. Percentage frequency is into 100. Percentage frequency is frequency by total frequency into 100, represented in percentage. So frequency density is class interval specific. Frequency of that class interval divided by class size of that class interval. Whereas relative frequency and percentage frequency is related to the entire class interval. Relative frequency is frequency of a particular class interval divided by total frequency. Same presented in percentage is percentage frequency. Clear? Practical questions can be asked in these calculations. Everyone understood?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes. The last discussion in this chapter, graphical representation. There we discussed diagrammatic representation, extension of this graphical representation, histogram or area diagram. This is similar to
Bar diagram.
bar diagram. The only thing is histogram is used normally for a continuous distribution. Bar diagram will be used normally for a raw data or a discrete distribution. There, in bar diagrams, you would be having gaps between adjacent bars. Here, no gaps between adjacent bars. It will be clubbed together. Correct? This is a very convenient way to represent a frequency distribution. It helps us to get an idea of the frequency curve. Comparison becomes possible. Very important point is the last one. It's not that important points should come first. Important points can always be at the last also. To draw a histogram, class limits are converted to class boundaries. Very important. Histograms, class boundaries. We will use class boundaries in case of histograms, and a series of adjacent rectangles, one against each class interval, should be drawn. So histogram, class boundaries. Next one, frequency polygon. This is similar to
Line diagram.
Line diagram.
yes, line diagram. Similar to a line diagram. What happens here is we would draw a line diagram itself, but we have to close this line diagram. How do we close the line diagram? We would draw this, we would join this to 0 and join this to the next value in the x-axis so that we get the polygon. Correct? This is called frequency polygon. It is meant for single frequency distribution. However, you can use it for a continuous distribution. Also, the condition is if you want to use it for continuous distribution, width of the class interval should be the same. Width of the class interval should be the same. And yes, we have to use midpoints of the class intervals. To draw frequency polygon, we have to use midpoints of the class intervals because we have we cannot draw one single point for entire class interval. You should have a representative for that. So frequency polygon, midpoint. Frequency polygon, midpoint. Histogram, class boundaries. The next one that we have is ogives or cumulative frequency graph. Here, it's similar to frequency polygon, but here we draw curves, not straight lines. We draw curves. Point number 2. In frequency polygon, we were using frequencies. Here we use cumulative frequencies. Correct? So we can have two types of ogives. One is less than type ogive.
More
If we
More
use
than.
cumulative frequency less than type, more than cumulative frequency, more than time. Correct?
Yes, sir.
Then,
Yes, sir.
yes. So there are two types of ogives. Can we draw both ogives simultaneously in the same
Yes,
chart?
sir.
Yes,
To
sir.
find median
Yes,
or
sir.
quadrant.
Yes, we can do that. Once we have both the ogives in the same chart, that midpoint, if I draw a line perpendicular to
Median.
x-axis, we get
Median.
Median.
median. Very
Median.
important. Yes, we get median. So through ogives, we can calculate median. We can calculate median. Then next one is frequency curve. Frequency curve. Now it's a extension of frequency polygon. Frequency polygon has straight lines. Frequency curve will have a curve. Okay, frequency curve will have curves. A smooth curve. In that frequency curve, the area inside the frequency curve is considered as unity. What do we understand by unity?
Its sum should be 1.
1. The sum should be 1. Very good. It's a limiting form of histogram frequency polygon. Now, how do we get the frequency curve? We can draw it directly, or alternatively, we would have drawn histogram like this.
Midpoint of histogram.
So in this rectangular bars, we can get the midpoints. Join the midpoints of histogram, you will get the frequency curve. Join the midpoints of the histogram, we will get the frequency curve. So these are some specific points. I'm just focusing on those points which are important from examination. So these are specific points which can be asked. In case of frequency curve, we have 4 different types. Bell-shaped curve, which we will be learning again in the future. Theoretical distribution, normal curve. It's a bell-shaped curve, correct? So what happens here? To start with, it will have less value, maximum value at the peak, and again falls down. Whereas next one is U-shaped curve. Here at the start, maximum value, falls down, minimum value at the middle, and again reaches the top. J-shaped curve, to start with, it will have less. It reaches the maximum at the end. It can also be inverted J shape, where to start with, it have maximum, becomes minimum at the end. Or mixed curve, combination of any of these 3. That is mixed curve. Okay, these are the 4 different types of frequency curves. That's it. This is chapter number 1. Any doubts?
No, sir.
No, sir.
No, sir.
Inside the head? Yes?
Yes, sir.
Okay. Can we look into the next chapter? Second one. Second chapter. Very important chapter, as we said.
Yes, sir.
Almost 40%, 30 to 40% of entire statistics is covered in this chapter itself. So measures of central tendency and dispersion. We have 2 discussions here. Measures of central tendency, measures of dispersion. What is central tendency? Central tendency is the tendency of all the observations to cluster around that central value. That central value is called average or measures of central tendency. Correct? So to calculate these central tendencies, we have different measures. We have different measures. How do you determine which is the measure that you have to take? For that, there are ideal measures, criteria for ideal measure of central tendency. It should be properly and unambiguously defined, easy to comprehend, easy to understand, simple to calculate. It should be based on all the observations. It should have certain desirable mathematical properties, should be least affected by the presence of extreme observations. So based on that, there are various measures of central tendencies. 5 of them are there in our syllabus. First one is arithmetic mean, which we already know. What is arithmetic mean? Sum of all the observations divided by number of observations. So if it is raw data, summation x by n. If it is discrete or continuous data, summation
Fx by n.
X by N.
Correct. So how do we calculate? In case of discrete data, if you have x and f, you will calculate fx, summation fx. What is n? Sum of all the frequencies.
Sum of all the frequencies.
If it is a continuous data, if you have class intervals and frequencies, first step is to calculate x, midpoint of the class intervals, then fx, summation fx by n. N is sum of f. Alternatively, we have one more formula to calculate this using assumed mean. So in that case, in case of large data, instead of multiplying f into x, wherein the calculations become too difficult, in that cases, we can use this. What do we do is, we'll assign one of the values as mean, assumed mean. We will assume it as mean. Normally, one of the x values will be considered as assumed mean. Correct? One of the x values. So that calculations become easy. So then what do? We will calculate d. What is d? X minus a by c. What is x? We know the midpoints. What is a?
Assumed
mean. Is c, size of the classifier.
Size of the
Correct? D is equal to x minus a by c. We will get d. Then normal. You have f, right? F into d. Summation f d. Summation f d divided by n into c. Since you had divided by c, multiply it. Since you had subtracted a, add a plus summation f d by n into c. That is the formula. If you can remember, not so important. But these two compulsory. That is bare minimum that we have to do. Correct? Those two formulas we have to remember. More important, in arithmetic mean, more than these calculations, properties are focused on. What are the properties that we have? If all the observations are same, constant, then what will be the arithmetic mean?
Then constant
Constant.
itself.
The constant itself. If the values are 3, 3, 3, and 3, what is arithmetic mean? 3
3.
itself.
3.
Next property, if we have x values, you calculate x bar, that is arithmetic mean. If you want to, you would subtract x minus x bar and add up summation x minus x bar. This value will always be 0.
0.
Will always be 0. In case of grouped frequency distribution, x, you will get class intervals, you will calculate x, you will have f, then you calculate fx and calculate arithmetic mean. After that, you will calculate x minus x bar, multiply it with f into x minus x bar. This sum will always be 0. Summation f into x minus x bar. Okay, they can ask questions. They can give you one set of data and ask you to calculate summation x minus x bar. In that case, you should not calculate x bar, x minus x bar, and then get the answer. You should directly tick 0 or shade 0. Okay, so you should not waste time there. Next, arithmetic mean is affected, or our friend, change of origin and change of scale. Arithmetic mean is affected by change of origin and change of scale. All measures of central tendencies get affected by change of origin and change of scale. So if y is equal to a plus b into x, if you want to calculate y bar, a plus b into x bar. Simple. If you want to calculate y bar, a plus b into x bar. Correct? That is the third property. The last one is combined arithmetic mean. If you have two different sets of data, first data has n1 values, x1 bar is the arithmetic mean. Second has n2 values, x2 bar is the arithmetic mean. If you want to calculate combined arithmetic mean, that is n1 x1 bar plus n2 x2 bar divided by n1 plus n2. n1 x1 bar plus n2 x2 bar divided by n1 plus n2. Correct? So these are the properties that we have. Important properties. These are the 4 important properties that we have to focus with regard to arithmetic mean. Next one is median. Median is also called as what? Positional average. Why? It's not calculated, it is located. Correct? So it is called positional average. It is the middlemost value in the given range, provided that observations are arranged in ascending or descending
Or
order.
descending.
So we have to arrange them in ascending or descending order, then identify the middlemost value. So if you have 1, 2, 3, 4, and 5, what is the median?
3.
3.
Three.
Middlemost value is 3. Correct? Whereas you will, if you have 1, 2, 3, 4, what is the middlemost value? What is the median?
2 plus 3
1
divided.
plus 3 divided by 2.
When we have two middle values, take the average. 2 plus 3 divided by 2. 2.5 is the median. Clear?
Yes, sir.
Yes.
This is for raw data. The raw data. If we have grouped data, that is continuous or discrete data. In case of discrete data also we can easily find out, but in case of continuous, we have this formula. L1 plus n by 2 minus NL divided by NU minus NL into C. Very important formula. What is L1? It is lower
Median.
class boundary.
As boundary.
Lower class boundary of the median class. So for that, first you have to identify the median class. How do you identify the median class?
N by 2.
N by 2.
N by 2.
Very good. N by 2. Now, in case of calculation of median, do we use frequencies or cumulative frequencies?
Frequencies.
Cumulative frequency.
Cumulative.
Cumulative frequency. Why? Because we want to identify the median class. To identify the median class, we want cumulative frequencies. So where this particular n by 2 value situates, that is the median class. Correct? That is a median class. In that, so from once you have identified the median class, the other class intervals are irrelevant for us. Only median class. Correct? So there you will find out the lower class boundary. N by 2 is already calculated. NL is cumulative frequency of the pre-median class. Pre-median class. NU is the cumulative frequency of the median class. It's not post-median, it's the median class. And C is the class width. C is the class width. Simple.
Yes, sir.
Yes. So we have to remember this. That's it. L1 plus n by 2 minus NL divided by NU minus NL into C. That is the formula for calculating median continuous distribution. Same way, it has properties, same properties that we have discussed. Change of scale and change of origin. Y is equal to A plus BX. Median of Y can be calculated by A plus B into median of X. But here, one important property of median, sum of absolute deviations minimum when the deviations are taken from median. What was the property that we discussed in mean? Sum of the deviations of the mean of the values from the mean is 0. Sum of deviation, x minus x bar. Here they are talking about sum of absolute deviation. Absolute means median modulus, ignoring the negative signs, correct? So x minus median. So if you calculate summation modulus of x minus x bar, summation modulus of x minus median, summation modulus of x minus mode, in this would be the least value always. Sum of absolute deviation would be minimum when the deviation is taken from median. Okay, this is about median. Simple. In case of raw data and discrete data, we know how we have to just locate it. In case of continuous data, we'll use this formula. First, identify median class, then use the formula. Second, with regard to properties, one property is important, absolute deviation related property. Next, before going into mode, extension of median, partition values. What are partition values? As the name itself says, they divide the observation into different parts, but those parts are equal parts. Correct? Median is also a partition value. Median divides the observation into how many equal parts?
Two
Two equal
parts.
parts.
Two equal parts. Correct. Two equal parts. Then, so we have only one median. Next, we have quartiles. Divide the observation into
Four equal
Four equal
parts. How many quartiles we have?
3 quarters.
Three
quarters.
quarters.
Three quartiles. Then percentiles, or rather deciles. Deciles divide the observation into
10
Ten.
10 equal
Ten.
parts.
equal parts. We have
9.
9
9
deciles.
deciles.
9 deciles. And the last one, percentiles divide the observation into
100
100 equal parts.
equal parts. We have
99%.
99%.
how many percentiles?
99%.
99%.
99%. Audible?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. Now, with regard to these partition values or quartiles, what we have to discuss? for calculation of quartiles, deciles, percentiles, the same concept of median that we have to use. In case of median, what we were doing, we were dividing the observation into 2. So in case of raw data, we were doing n plus 1 by 2. Correct? In data, we were doing n by 2. But here, in case of quartiles, what do we do? For first quartile, n plus 1 by 4. Second quartile, 2 into n plus 1 by 4. Third quartile, 3 into n plus 1 by 4. This is for raw data. In case of discrete data, n by 4, 2n by 4, 3n by 4. Correct?
3n by. Yes, sir.
Yes, sir.
Yes.
Is there a lag?
Yes, sir.
Yes, sir.
Sir, you are not audible.
Just a second. Now?
Yes, sir. Now you are audible.
Yes, sir.
Now better. I'm audible. I'm
Yes, sir.
visible.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Okay, right. So I'll just repeat what I said with regard to partition values. Calculation of partition values, calculation of median. How do we do? N plus 1 by 2. In case of raw data, it would be n plus 1 by 2. In case of discrete or continuous, it would be n by 2 to get the median class. Same way, in case of quartiles, there are 3 quartiles that we have to calculate: Q1, Q2, and Q3. Q1 would be n plus 1 by 4. Q2 would be 2 times of n plus 1 by 4. Q3 would be 3 into n plus 1 by 4. Same way, in case of discrete or continuous,
N
n
by
by 4, 2n by 4, 3n by 4.
3n.
Correct? Same way, in case of deciles, you will use by 10. In case of percentiles, divided by 100.
100.
100.
So if you want 8th decile for a discrete data, it would be 8n by 10.
8n by 10.
If you want 37th percentile, it would be 37
37n by
100. Correct. 37n by 100. Yes. Another way, instead of calculating, if you want to find it through diagrammatic representation, you can use ogives. Correct? But if you have both ogives, if you want median or Q2 or D5 or P50, you can draw both ogives. But just by drawing less than type ogive, you can calculate all quartiles also: Q1, Q2, Q3, all deciles or percentiles. How? We have to just point out the value, that the NP value, n plus 1 by 4 or n by 4, that value, since this is cumulative frequency, locate that value, draw the line, you'll get that particular quartile, decile, or percentile. Okay, that's all. This is about partition value, a small discussion. The last, in this particular discussion, mode, we still have 2 more measures of central tendency. One is mode. What's mode? That value which occurs maximum number of times. So in case of data, very easy. You have to just identify which is the value that is repeated more number of times. That would be the mode. In case of discrete data also, it's easy. Why? That particular
More
value of
Frequency.
the highest, correct? Highest frequency will give you the mode. But in case of continuous data, you can identify the class interval having highest frequency, that becomes a modal class. From that, you have to calculate mode. Correct? From that, you have to calculate mode. How do we calculate mode? Using the formula. First, you have to identify the modal class. Then you have to apply this formula. L1, this remains the same. But from here, in median formula, you had all cumulative frequencies. Here, only frequencies. So F0 minus F minus 1 divided by 2 times of F0 minus F1 minus F minus 1 into C. So what are we doing? In the numerator, current class's frequency minus previous frequency divided by 2 times of current class frequency minus previous frequency, next frequency. Previous frequency, next frequency. That gives us this calculation into C plus L1. What is L1? Lower class boundary of the model class. How to identify the model class? We have already discussed. When we learnt about mean and median, any given frequency distribution, we will have one median, we will have one mode for sure. Sorry, one median and one mean. But mode need not be the same.
Multimodal distribution.
Yeah, for certain distributions, you can have only one mode. For certain distributions, you can have more than one mode. It can be two modes, which we call bimodal, more than two also, 3, 4, etc. In some distributions, it can be zero mode also, where there is no repetition at all. Zero modes also. So mode need not be distinct. There can be more than one mode. It is called multimodal distributions. Bimodal distribution will have two modes. Property, same property. Y is equal to a plus b into x. Mode of y will be a plus b into mode of x. Clear with this?
Yes, sir.
Yes.
Yes, sir.
Yes. Now we have empirical relationship, very important relationship. Practical questions can be asked from this. Mean minus mode is equal to 3 times mean minus median. Or alternatively, if we can simplify, mode is equal to 3 median minus 2 mean. Mode is equal to 3 median minus 2 mean. Either of it you have to remember. Okay, one of these, mean minus mode is equal to 3 times mean minus median. Mode is equal to 3 median minus 2 mean. Very important relationship. Empirical relationship. After that, we have geometric mean and harmonic mean. Now, geometric mean, how do we calculate geometric mean? If we have 1, 3, and 5, I have to multiply all the 3. 1 into 3 into 5, and then take cube root, because we have 3 observations. So, product of the observations, then nth root. Nth root of the product of the observations will give us geometric mean. For grouped frequency distribution, x1 to the power of that frequency into x2 power of that frequency into x3 power of that frequency, nth root. Total frequency, sum of the frequency. Obviously, that is not our concern now. Some simple geometric mean calculations can be asked. Okay, without using scientific. Obviously, scientific calculator is not allowed in the exam. We are aware of it. Only normal calculator. So, whichever calculations can be done through normal calculators, those things can be asked in the exam. Calculation of geometric mean. Okay, so those who are still using scientific calculator, stop it immediately. Use that calculator which you will use in exam. Don't buy a fresh brand new calculator for examination. No, don't open the cover of the calculators in the examination hall. No, you should not do that. If you are planning to buy a new calculator for examination, buy it now itself, so that you are used to the operation of that calculator. Okay, so you are using the same calculator that you are using in the examination, so that you will get used to it. You can calculate quickly. Now, how do we calculate fourth root in a simple calculator?
Square root twice.
Square root twice. Yes. Properties of geometric mean. Calculation is difficult, so properties are focused on. Properties become very, very, very important. So what is the first property? Now, if you want to calculate geometric mean, it can be calculated in either way. Logarithm of a particular geometric mean that you want to calculate would be equal to sum of logarithms of the values divided by the number of values. That means logarithm of geometric mean for a set of observation is the arithmetic mean of logarithm of the observation. So summation log x by n will give you the logarithm of geometric mean. Now, if all the observations are constant, geometric mean is that constant itself. Same. 2, 2, and 2. 2, 2, 2 is 8. The cube root of it is again 2. Geometric mean, now if you know that z is equal to x into y, logarithm of z will be equal to
Logarithm of x plus logarithm of y.
Yeah, this is geometric mean. Logarithm will come later, mathematics. So geometric mean of z is equal to geometric mean of x into geometric mean. Same way, if z is equal to x divided by y, geometric mean of z will be equal to
Geometric mean of x
Geometric
plus
mean
geometric mean of
x
y.
x divided by geometric mean of y. The disadvantage is difficult to calculate. So these four properties very, very important. The last measure of central tendency, harmonic mean. Now, what is harmonic mean? The definition, reciprocal of arithmetic mean of reciprocal of the observation. If you have not understood the definition, nothing to worry. In case of raw data, now how do you calculate arithmetic mean? Summation x by n.
X by n.
You have to reverse n divided by this. This also you have to reverse summation 1 by x. So reverse the reverse. That's all. This you reverse, that is find out the reciprocal n by summation x. Denominator also would be reciprocal summation 1 by x. This is for raw data. For continuous or discrete data, it would be n divided by summation, instead of 1 by x, f by x. Summation n by x, it would be summation f by x. Again, here some simple calculations can be asked, but more than that, properties in that combined harmonic mean property is very important. If all the observations are constant, harmonic mean is constant, that we already know. Combined harmonic mean, we have discussed combined arithmetic mean, n1 x1 bar plus
n2 x2 bar divided by n1 plus n2.
Divided by n1 plus n2, correct. Same way, you have to, what we will do in harmonic mean, we will reverse. So n1 plus n2 would be the numerator, divided by, instead of n1 x1 bar, n1, harmonic mean is always reciprocal, so n divided by h1 plus n. That gives us combined harmonic mean. Very, very important formula. Rochelle, understood? Yes. Okay. Now, we have discussed empirical relationship between mean, median, and mode. Same way, we have relationship between arithmetic mean, geometric mean, and harmonic mean. Geometric mean is equal to square root of arithmetic mean into harmonic mean, or G square is equal to A into H. And always arithmetic mean would be greater than or equal to geometric mean, greater than or equal to harmonic mean. Okay. Weighted average is not so important. So weighted average is same. Instead of frequency, we will use W. Summation fx by n. Here we will use summation wx by summation w. Right? Same concept. When we will use arithmetic mean, geometric mean, harmonic mean, very important discussion. Arithmetic mean is the most commonly used. Whenever they ask for average calculation, we will use arithmetic mean only, except for these two cases. Geometric mean is for average of percentages. If they give us percentage, okay, percentages, and they are asking us to calculate average of it, geometric mean. If they are giving us speed, they are asking us to calculate average, harmonic mean. We cannot use arithmetic mean. In case of speed, harmonic mean. This is the most commonly asked question. In most of the exams, they have asked this. Calculate average speed. We should use what? Always harmonic mean. We should not use.
Sir, for ratios also we use geometric mean.
Ratios, percentages, geometric mean.
Okay.
Yes. Then last concept before starting measures of dispersion. This is comparison among the central tendencies. Which is the best measure of central tendency?
Arithmetic mean.
Arithmetic mean. Because it is rigidly defined. We have a formula based on all observations, easy to comprehend, simple to compute, and amenable to mathematical properties. This paragraph is very important. Okay, these points. However, what is the disadvantage of arithmetic mean? Fluctuation by sampling fluctuations. It gets affected by sampling fluctuation. And it is not possible to calculate arithmetic mean for open-ended class intervals. We cannot get x at all in case of open-ended class interval for the first and the last class interval. Correct? Same. Likewise, for median. Median is also rigidly defined, easy to comprehend and compute. But the greatest advantage of median is it is most suited for open-ended class interval. Very important advantage for median. For open-ended class intervals, median. And median is not affected by sampling fluctuations, but disadvantage. In calculation of median, we are only focused on central values. It is not based on all observations and does not allow itself to mathematical treatment. Mode. Although mode is most popular measure, there are cases where mode is undefined. We have discussed that in certain class intervals, there can or certain frequency distributions, there cannot be, there are chances that mode is not at all there. For example, 1, 2, 3, 4, 5. For this range of observations, what is the mode? There is no
Zero.
mode.
Zero.
Mode is undefined. Mode cannot be 0. Mode is undefined. We cannot say mode is 0. Mode is undefined. Correct? So mode is undefined. So that is one drawback there. Right? And unlike mean, there is no mathematical properties. Mode is also affected by sampling fluctuations. Geometric mean and harmonic mean advantage is they are amenable to mathematical properties. Further statistical analysis is possible. They are rigidly defined and they are based on all observations. But what is the disadvantage? Why arithmetic mean becomes most popular than geometric mean, harmonic mean?
It is easy to calculate.
Ease of calculation and comprehension, understanding. Correct? They are difficult to comprehend and compute and have limited applications. That is why they have limited applications. That's it. So
Sir,
with this,
affected by,
we are done with measures of central tendency. Yes. Anyone has any doubts?
sir, harmonic mean, geometric mean, and arithmetic mean, sir, they are affected by large samples, no, sir?
Sample fluctuations. All the three are affected by sampling fluctuations. Yes.
Okay, sir.
Yes. So in that area, median is the best measure. Median is less affected by sampling fluctuations, and obviously open-ended class interval.
Okay, sir.
Clear with what? So in today's class, yes, we only discussed about concepts. We didn't solve any problems. I understand it could have been a little boring for some of us, and some of us would have slept also by now. Fine. Tomorrow's session, before tomorrow's session, all whatever we have discussed till now, everyone should have read. Right? We'll start with the question and answer session only. We'll start with questions. Then only we'll go with measures of dispersion. Measures of dispersion, very few concept that is left, small discussion. Then we can start with the problems in the next class. Is that fine?
Yes. Yes.
Yes, sir.
Okay, fine. We'll continue in the next class. Anyone has any doubts before that?
Sir, before all the classes, sir, could you please say about what we will be doing in next class so that we'll prepare in advance and then it would be easy.
That's fine. That's not a problem. Anyhow, we are doing statistics only. I'll definitely not go beyond statistics, maths, and logical reasoning. That's for sure.
Okay, sir.
Yes. Someone had Ashwini, you had something to say? You had unmuted yourself.
No, sir.
No. Okay. Right then. We'll continue in the next class. Anyhow, we'll be continuing this chapter itself. We'll be solving problems. Yes, Suman, tell me.
Sir, we should take the printout of revision notes, sir, for upcoming classes.
Suggested to take so that it will be easy for you. Okay, referring soft copy would be difficult because we'll be quickly looking into the problems and solving it. So suggested to take the print of it.
Sir, in ICI material, we have 1 marker, 2 marker, 5 marker separately. In exam, how will they give it, sir?
In
Separate.
exam, everything will be 1 marker. 5 markers also will be asked as 1 marker.
Okay, sir.
Yes.
Thank you, sir.
Again, that's a good point actually. Time management. We will discuss over the period because we have only 2 hours. This is not a 3-hour paper. 2 hours, 120 minutes, 100 marks, 120 minutes we have to complete. So how do we manage time? That also we have to discuss. We will discuss about it.
Okay, sir.
Yeah. We'll continue in the next class. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.